Well, hello again, mathletes, and welcome back. So today what we're going to be doing is, I don't know how to put it. We're not exactly learning something new. We're learning something new about stuff we already know. So what we've done, we've gone through the trig functions, what their definitions are, how to find different values of them. But one of the things that pops up quite often is when you're given a limited amount of information about an angle and you have to figure out what the trig functions are. So we're going to take a look at that today. And so without going any further, let's go ahead to take a look at the first idea here. Um, let's see, make sure I have my pen on, everything's set. Okay, good. Um, let's look at this. So suppose the point -4, 3 is a point on the terminal side of theta, right? Find all 6 trig function values. Now, this is one of those ones, this is one of those types of problems where once you start to draw it out, it's really not that different than what a lot of the stuff that we've been doing. So let's go ahead. It really feels like there's not enough information just to start out with. But if we start with graphing this point, like I'm just going to kind of eye this in. So that, let's say that's -4 and that's 3. So here's our point here. We're told that this is a point on the terminal side of theta. So that what that's saying is that there's an angle theta that's in standard position so that I have one side here and the other side is a little crooked, but it goes through that point, right? Now, here's how you end up handling this. That point is giving you an x and a y coordinate. So you can force a little right triangle here. And since this point has a height of 3, that means this side of the triangle is 3. And this side of the triangle over here has a length of 4. But because of the fact that we are dealing with the x-axis, we're going to consider this side length -4. Since the coordinate has an x-coordinate of -4, we're going to think of these distant, or these, yeah, I guess they're a distance, but the length of these sides can now be negative if we're counting them on the x-axis. So if we look at this now, what we can do is use the Pythagorean theorem, because those are two legs of a right triangle. 3 squared plus -4 squared is going to give us our radius squared. And that gives me 9 plus 16 is equal to r squared, which is 25 equals r squared. The radius is the one exception to the possibility of having a negative length. The radius is never, ever negative. So if 25 is equal to r squared, then r is equal to 5. So now we have the 3 sides of the triangle. We're back in the ballpark we were in before, where we start looking at opposite over hypotenuse, adjacent over hypotenuse, and all those things. So now that we have all that ironed out, and keep in mind, theta is actually this outside angle. Okay, so sine theta, right, is going to be, and we're counting it over here now, opposite over hypotenuse, which is 3/5. Cosine theta is the adjacent over the hypotenuse, and this is why we keep the negative, is because here cosine is negative, right? So it's -4 over 5. And it makes sense that cosine would be negative, because remember, on the unit circle, cosine is an x-coordinate, and on the left-hand side of the y-axis, right, everything that's this direction has a negative x-coordinate, right, because it's on this side It's on, yeah, it's on the left-hand side of the y-axis, which means that it has to be negative. Now, once we have that, let's see here. Tangent then would be opposite over adjacent, so that's negative 3/4. Let's see here now. Secant is the reciprocal of cosine. So cosine was negative 4/5, so secant is negative 5/4. Cosecant, cosecant is the reciprocal of sine, so that means it's positive 5/3. And cotangent is the reciprocal of tangent. You can see how important it is to know these reciprocals. It makes a huge difference later on. It's reciprocal of tangent, so that means it is negative 4/3, right? So we have all 6 trig functions, and you notice it just came out of the drawing. Once you have the drawing and you have a couple of sides measured out, you can deduce everything from there. If you're missing a side of the triangle, you use the Pythagorean theorem to find the other side, and then you have all of your ratios. But it's a matter of getting a good drawing here. You know, this kind of drawing is really, 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 really valuable here. Okay, so that's our first example, and let's go ahead and get rid of this guy. Okay, so here's what I would like you guys to do. This is one for you guys to try. The same thing, so the point -1, -3 is on the terminal side of theta. Find the other trig functions. Sorry, my handwriting's getting worse here. There we are. Ah, that's not what I wanted. Let's try that again. Okay, yeah, I know I kind of scrawled that out really fast, but it's the same problem as the last one, just with a different point. So go ahead and pause it here and see what you can do. Okay, now let's take a look here. So we're going to start with a drawing. We're going to see which quadrant this lies in. And one of the things that you want to remember that's really going to come in useful, you know, we have an x and a y axis, but anything below the x-axis is going to have sign be negative because that's where all your y values are negative. It's the things that are on the bottom side of the y-axis. And same thing with cosine. Anything to the left of the y-axis is going to make cosine negative as well. So just keep that in mind. That's one of those things. I know your book actually kind of maps it out by quadrants, saying, you know, you have the 4 quadrants here. And I guess I'll put it here. You know, you have your 4 quadrants, 1, 2, 3, and 4. And they'll say, well, cosine is negative in quadrants 2 and 3, and sine is negative in quadrants 3 and 4. It's really, don't think of it in quadrants. Think about it in terms of what side of the axis that it's on. And it really helps out. Okay, so let's go ahead and take a look here. So we have the point -1, -3. So that puts it, let's see, -1, and let's say -3 is down here. So that point is down here somewhere. And again, you know, the angle we're talking, oh, that's a terrible drawing, but the angle we're talking about is right here, right? This is theta. Yeesh. That's going to just bother me until I fix it. Right, this angle right here is our theta. So theta is bigger than 180 degrees, and it's smaller than 270 degrees. Again, we don't have to know what the angle measurement is. We just need to figure out what the signs of the x and y coordinates are, and we already have those. I have a -1 and a -3, which puts it in the 3rd quadrant here. So let's go ahead and work it out. Actually, you know what? I'm going to draw this a little bit bigger. I'm just going to move this point over. I'm going to say, just so we have a bigger thing, I'm going to say that's -3 and that's -1. Okay, so what that means is that this side of the triangle here, this side furthest south, is -1, and this side is you can tell I'm getting tired. um, that side is -3. So we have two negative sides of the triangle right now. And we need to find the other side if we're going to find all six trig functions. So we'll use the Pythagorean theorem again. So -1 squared plus -3 squared equals r squared. That's 1 plus 9, so that's 10 equals r squared, which means that the square root of 10 is equal to r, which means that we have to deal with a square root this time. And that's okay. We don't mind dealing with square roots. Square roots are happy. Okay, now, excuse me. Let's see here. So we found all three sides. Yeah, now we just need to march through the trig functions. And with a square root, you do, especially since it's the hypotenuse of this triangle, that means your denominators are going to be square roots, which means that you're going to be rationalizing the denominator as you go here. Okay, so for sine, if we start out with sine, let's see, our triangle's down here. I'm really kind of thinking of this angle. So the opposite over the hypotenuse is -1 over the square root of 10. Well, I can't have a square root on the bottom, so you remember we multiply top and bottom by the square root of 10, and I end up with -√10 over 10. So that works out real nice. Cosine, let's see here. Cosine's the adjacent side over the hypotenuse would be -3 over 10, root 10. And if I take the square root there, or if I rationalize the denominator here, I get -3 root 10 over 10. Okay, so we have two of these now. And now we have tangent here, and tangent is opposite over adjacent. So that's -1 over -3, and a negative divided by a negative makes it positive. Excuse me. Okay, so let's do the other ones. And I'm just going to do it by reciprocal directly. Cosecant theta is the reciprocal of sine. Now, I don't want to take this reciprocal because that puts the square root back on the bottom. So I'm going to use this one instead. As part of the reason I kept it in the computation is because if I take that reciprocal, cosecant is just negative square root 10. Secant, I always think of the Bible when I think of secant because, in the Beatitudes, he did say, secant you shall find. So, we're getting closer to God here, guys. Okay, so the reciprocal of cosine, again, I'm not going to use this reciprocal. I'm going to look at this one with the denominator of root 10, because if I take that reciprocal, I don't have to rationalize the denominator. And then it's cotangent. With cotangent, we just flip tangent over. So it would be 1 over 3. It's 3 over 1, which is just 3, right? And you notice something. One of the things that you will notice is that sine and cosine are always numbers that are smaller than 1. Pretty much everything else gets bigger than 1. Right? Tangent, secant, cosecant, and cotangent are all things that get bigger than 1, but sine and cosine are restricted. You can never have a value of sine bigger than 1 and never have a value of sine less than -1, and the same thing goes with cosine. Okay, so let's see here. Yeah, we got through that one. Excellent. So let's go ahead and delete that. So we got that covered, and we'll look at the next example. Okay. So here's our next problem. So given that cosine theta is equal to -2/3 in quadrant 3, find the other trig functions. And so, there's this question of why does it say quadrant 3? Why does that matter? Why can't I just use -2/3 and go? Well, let's take a look at that. Okay, remember that in the unit circle, x is equal to cosine theta. right? So if I say cosine theta is equal to negative 2/3, that's saying x is equal to negative 2/3. Well, here's the problem with that. Here's negative 2/3, right? Um, Depending on what sine is, if we don't know what sine is, right, we only have one of the coordinates, I don't know if I'm on this side or on this side, right? And that's going to change what the sign of sine is. In fact, it changes the signs of many of the trig functions if you have that wrong. So you do need to know which quadrant you're in, because when you make your triangle, I'm going to make it on the top part just because. If it's in quadrant 2 when I make my triangle here, what ends up happening is that I have a negative here for the adjacent side, but I have a positive for the opposite side. If I put it down here, I would have a negative for the opposite side, right? And so it's going to determine what sine is. Okay, so let me get that off of there, and we'll actually take a look now. The fact that it's in the third quadrant means that we're talking down here somewhere, right? Sine is 2/3, or yeah, cosine is 2/3. So this is fudging a little bit, but it really is a nice tool to do this. I'm going to go ahead and draw in this triangle like we always do. I know in the third quadrant, both the x and the y coordinates are negative, which means that whatever I measure on this side is going to be negative, and on this side, right, the hypotenuse is always going to be measured positive. So we know that this side, right, is the adjacent. This side is the opposite, and this side is the radius. The fact that we're told cosine is 2/3, we can actually cheat here and just act like this is the previous kind of problem, and that is the adjacent side, and that is the hypotenuse. So I'm going to change it to this. I'm going to change this to, that looks like a +3, so that's +3, and I'm going to change the adjacent side to -2. Now we can figure out what this last side is and go from there using the Pythagorean theorem. So the Pythagorean theorem says that -2 squared, and this is my y coordinate, plus y squared is equal to 3 squared. Well, that means 4 plus y is equal to 9. And if I subtract that, I get, y squared. Y squared is equal to 5, so y is equal to the square root of 5. So now I have that. So this is now the negative square root of 5. We have all three triangles, right? Once you are all three sides of the triangle, that's what I meant. Once you have all three sides of the triangle, it's very straightforward. All you need to do is just compute the ratios. We already know cosine theta is -2/3, right? Sine theta then, right, if I'm looking at this angle, sine theta would be the opposite over the hypotenuse, so it's -√5/3. Cosine we already figured out, right? It's -2/3. We're given that right from the start. So tangent is the opposite over the adjacent. So it's a negative divided by a negative, which means it's +5/2. And then cosecant is the reciprocal of sine, so it's also going to be negative. That makes it 3/√5. We have to rationalize the denominator, so this is now -3√5/5. Secant is the reciprocal of cosine. Theta. I forgot my little angles. Where was I? Oh, yeah. Secant's reciprocal of cosine, so it's -3/2, and then cotangent is the reciprocal of tangent. So that makes it 2/√5, and it's positive. Now I need to rationalize that, so that's 2√5/5. Now, you notice the pattern with rationalization. Once you've done a few of them, you start to notice that pattern. You stop needing to multiply. as far as the square roots go. It starts to become very natural. So think about it as you do it. And, even test yourself. See if you can rationalize it in your head and then work it out by hand and see if you get the same answer. So as long as you can, you're in good shape. Okay. So that actually wraps up everything we needed to talk about. What we really did more than anything else was take what we already knew about side and cosine and tangent and all the other ones, um, and we just applied it in a new situation. Right? These are the types of things that you really end up doing this in math all the time. You end up climbing through things that you do know and trying to build something that you can use with what you don't know. So in any case, that concludes our lecture for this week. And so until next time, keep your pencils and your wits sharp.